Hello class, in this video we will talk about the basics of circles. So first let us define what is a circle. So the set of all points equidistant from a point or center. You are already familiar with this, you can see this everywhere. So this is an example of a circle and this is how it is defined in math, particularly in geometry. So point Z here would be our center and this black boundary beyond this pink shade right here, the black boundary, that is our circle. So from this point here, Z, the center, to any point on the circle here, the black boundary, right here, or anywhere here. So any line segment that you can create towards the boundary from the center, that is the same distance, equidistant. Example maybe this. So this distance here, this segment is called a radius. So we usually use R for radius. So you can also create another radius here, 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 for as long as you create it from the center to the boundary, to the circle. So that would be our radius, in plural, radii. And an example for that would be, say, this Ferris wheel. So the blue boundary, let's consider that as the circle, and its center is right here. And these spokes, these white spokes, will be our radii. Okay, that's it. So to name a circle, simply use the name of the center. And you guess it right, the yellow circle here is named circle Z. And you can also use the symbol to pertain to circle. And yes, you are correct again that the blue is called circle V. I know you know this. Now let's proceed with the regions. There are three regions. First, we have on the circle, the boundary itself, the circle itself. These are the points on the circle. Next, we have the interior, no? As the name suggests, interior, inside. So the green shade, including the center, that's inside this boundary or this circle. And of course, you guess it right, the third would be exterior or the outside. So as the name suggests, uh, these are how it is defined, but we already are familiar with outside. So that would be beyond the black boundary, beyond the circle. So that would be anywhere here. Example could be at this point, anywhere. So that's our regions involved in a circle. Now, for an example, let us consider this yummy pizza, right? Yummy. So the crust would be our on the circle, and all the yumminess, that would be the interior, the dough and the toppings. And the exterior would be outside the pizza, of course. So that's it. Now we have segments as well. We can call it a chord if the endpoints of the segment is on the circle. As you can see, A and B, the endpoints of this red segment is on the circle. That means this is a chord. So we can name this chord AB, and you guess it right. The other chord you see down here is also a chord CD, and because D and C here, the endpoints are on the circle. And we have here an example, the glass art. You can see here the yellow line and the other metallic material here. These are chords of this circular object. Now another segment is called diameter. It is a special chord because it passes through the center. As you see here, the green chord here with endpoints A and E on the circle J is a diameter since it passes through point J, which is the center of circle J. Now it is actually made up of two collinear radii. JA here is a radius and JE is also a radius. So they are collinear, forming one complete segment, which is the diameter. Thus it has a formula. So D for diameter equals 2 times radius. So an example could be the complete slice of this pie, very delicious pie. It passes through this center. So right here you have many diameter. And next will be secant. Secant can be a line, segment, or ray for as long as it intersects the circle in 2 points. As you see here, the blue line F intersects circle J at this point. So this is an example of a secant, and real life example would be these sticks passing through the circular part of this whole steering wheel of a boat. So all of these sticks are secant to the circular part, and it passes through 2 points. As you see here, this stick passes through these 2 points of this circular part. And last, we have tangent. Similarly, line, segment, ray, but it only intersect once. So ray GA here is a tangent where its point of tangency is point A. So ray GA, we can say that they are this is tangent with circle J at point A. So point A is the point of tangency. So these are theorems, and you can read that. You can even search more about that. But let's just move forward. So example would be the rubber part, and of course this beautiful road, no? Very beautiful inventions. So the road is tangent with the rubber part of the wheel. So somewhere here is the point of tangency between the rubber and the cement. And that's it. So these are the segments again. And we also have the properties. So for a chord, it cut the circle into 2 parts. So you can see here CD cuts the circle right here, the lower part and the upper part. For a diameter, it cuts the circle in half. Since it passes to the center, it cuts it in half, which is called semicircle. So we have two semicircles here. And for the secant, it contains a chord. So as you see here, if we recolor that, that's a chord, no, contained by the secant and passes through the interior of this circle. And for a tangent, if you are familiar with the earlier theorem presented, so it is said to be perpendicular. So GA is perpendicular to the radius, where this radius must be drawn from the point of tangency to the center, of course. So it's perpendicular or forms 90 degrees. So again, these are the properties. Now let's go with concentric circles. So what are these? So concentric are just circles on the same plane, and they have the same center. They share the same center, like the blue circle L, the green circle L, and the yellow circle L. So these are concentric, and maybe you can see around you nice examples. I can show you this dartboard. So you see there the many circles being concentric, and right here the bullseye is our center. So how many circles do you see that are concentric? I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right now I only see 10. Maybe you can see more or less. Anyway, that is an example of concentric. Now let's proceed with tangent circles. So as the name suggests, they are coplanar circles that are tangent to the same line. So there are two scenarios externally tangent, when the two circles are tangent to the same line on opposite sides, like circle R on the left side, while circle F is on the right side of this line. So that's externally tangent, and internally tangent, they are on the same side of the line, being tangent to that line. So a real example could be this floor and the wheel of this motor. No, they are on the same side. Imagine that tangent line. And we have also Beyblades. So imagine a line here. They are on the opposite side of that line. So they are externally tangent. This is internally tangent. So as simple as that, class. That would be our basics of circles. Thank you for watching.